The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
The second method, which is the RAP document number 2, talks about using epoxies for gravity feed of cracks. Now, if the cracks are vertical in orientation, you cannot use this method because in this method, what you're doing is using the viscosity, gravity of using gravity to fill fine cracks and structurally bond the concrete. There's one thing I want to make sure that people understand, that when you're talking about a structural repair, epoxy injection is the best way to do it because you're injecting epoxy under pressure. If you're doing gravity feed, you can get a structural repair or you can bond the length of the crack to fuse together, but it's not that it happens all the time. So if it's a sealing operation and if it's fine cracks and if a structural crack is not needed, maybe you can use epoxy by gravity feed. But if you're really looking to bond those two pieces together all the way through the length of the crack, epoxy injection is the preferred way of doing it. Now, same purpose, right? If it's a crack, we want to keep the water out, the salt and the aggressive elements out of the concrete structure because they're not good for concrete. Once again, before you go ahead and inject something as rigid as an epoxy into cracks, we have to make sure that the cracks are basically static. If they're dynamic cracks and if they're moving cracks, it is just going to crack right next to it or somewhere else where it's going to find relieve its stresses. Okay, once again, like I said, this method of gravity feed, epoxy repair, is used only in horizontal elements, static cracking, and of course it will give you some kind of short-term corrosion protection, but if you have a rebar behind the crack that has active corrosion going on right now, it is not going to address that. There will be activity that will keep on going, but you will keep the moisture and the bad elements out of the concrete structure. This document talks about 2 different resins used in this particular application. The first one is epoxy. And the second one, which we know a little bit about, is high molecular weight methacrylates. The difference between the two, there are more commonalities in the two than the differences, really. They both are resin-based. They are very low viscosity. So they're like water. Once you mix them up, they're just like basically water and will penetrate fine cracks. Very easy to pour. And the difference is epoxies, typically in the marketplace right now, you will find epoxies which are in the range of 100 centipoise, which is very thin. But MMAs or HMWMs, which are high molecular weight methacrylates, they are in the range of about 50 centipoise. Epoxies have low surface tension, but methacrylates have even better surface tension, lower surface tension, and that basically is a function of how well you will penetrate into cracks. Epoxies do a great job bonding to damp concrete, whereas in methacrylates, the mixing ratio is not as critical. Epoxies are definitely rated higher for being safe in terms of their use. Methacrylates are a little tricky, and one has to be very careful if people are using methacrylates. Methacrylates have the advantage of a much more faster setting time than the epoxies. So both the resins can be used with success and are being used in the industry with success. One has to know the goods and the bads about each of this chemistry. If you're doing a small crack, and just basically not doing the entire surface area of crack repair, but it's just doing localized cracks, you would basically need a mixing bucket, drills, and mixing paddles. People typically would basically use a flat rubber squeegee and rollers. I even see people using ketchup bottles to inject epoxy into cracks, and that's a fair practice. You're doing gravity repair. There's nothing wrong with that. And if you're doing entire surface area, like a complete slab which has multiple cracks in it, and instead of doing localized cracks, you're trying to seal the entire slab, including the cracks, people typically use spray bars and seal the surface with that. Again, like I said, both the MMAs, methacrylates, and the epoxies are dangerous goods. They are hazardous in nature. One has to be very careful about the PPE aspect of it and make sure that we take the necessary precautions. For high molecular weight methacrylates, you make sure that we never combine the A and the B components directly and add the promoter to the monomer first. Preparation. If you're chasing a crack, basically, then you do not need to shot blast the area. You just have to make sure that the surface is free of contamination. But if you're doing an entire surface area where the epoxy is used as a sealer, you will have to shot blast the floor. But make sure if you're putting some air into the cracks, trying to get the dust out and the debris out of the crack, make sure that the compressed air that you're using is free of oil and there's an oil separator attached to it. Otherwise, you'll be blowing oil into the crack, which is, of course, not good for epoxy or MMAs to stick to it. Typically, these products need about 24 hours for them to cure. Mixing, like I said, they're typically formulated to some kind of ratio, 1:1, 2:1, 3:1. You make sure you mix it properly. Application. One interesting way of application that I've learned over the years in the industry is if you have a crack like this, people would use a cheap acrylic caulk around the width of the crack and basically create a sort of a dam and just pour the epoxy on top of the crack. And they will just go back and forth with squeegee on top of it and make sure they're forcing the resin into the crack to get maximum penetration. And once, of course, you're done with making sure that the epoxy has penetrated the cracks, you will basically take the cheap caulk off because you don't need that form anymore. You will probably apply some sand to the surface where you have some epoxy to make sure you do not end up with a very slick or a smooth surface. And that's it. And that is basically your application. Verification, once again, similar method really. You take out 2-inch cores and you watch it under blue light, and the resin will highlight, which we can see very clearly. You can try to break those cores by, and even there are some contractors which I have seen people will basically make sure that the epoxy hasn't mixed correctly. Will take specimens and break them to make sure that the strengths are fine. But the most critical aspect of epoxy injection or epoxy by gravity feed is to make sure that the resin gets into the cracks, because that's what the primary objective is. If you're doing a small area, like I said, multiple cracks, that is the way it's going to come out on the left-hand side. On the right-hand side, if you're doing an entire surface area, we're using cracks, and the rest of the area is also sealed with a low viscosity epoxy. That is the way the surface is going to look like. And I'll take any questions on both the documents if there are any.
Yes, sir?
Are there any UV considerations to that?
Please repeat the question.
The question that is asked was if there are any UV considerations for epoxy. If that's what I said, sir?
Yeah.
Epoxies do get affected by UV. The best way to protect them would be, first of all, you're doing a very small area, and if you broadcasting sand into it, you will definitely delay the effect of the UV on that particular resin. But inside the crack, as far as structurally bonding the elements together, that does not affect it at all.
Any other questions? I have one question. You mentioned about using heat to remove the cap seal on epoxy injection. Do you want to mention anything about the safety or care that should be taken in using that method?
Absolutely. It's not my preferred way of doing it, but people do it. You really have to use something like a torch gun to melt the epoxy. And it is not the preferred way of doing it, guys. You have to make sure your hands are very well protected, your eyes are very well protected, because you're just melting a cured piece of resin, which is about 9,000, 10,000 psi. So it's not good. The best way I've seen in the industry is to make sure you wear protection for respiration and grind it off. That is the preferred way of making sure the cap seal comes off. And if it is not needed, if you have a column that is not visible to anybody, you don't have to remove the cap seal. You can leave them as it is. It is not going to affect the performance of the install. It is just an eyesore, and if it's critical, you can remove it.
Very good. Thank you very much.
Thank you.